My name is Manfred Helber and I'm a Microsoft Most Valuable Professional in the category Cloud and Data Center. In this video, we will create volumes in different scenarios because there are differences in the opportunities you have in a 2-node, in a 3-node, in a 4 and more node cluster. We will have a video with a complete live demo, so everything we will see about the managing and creating volumes will be in a live demo. So we'll switch in this live demo environment now. If you remember or review the previous modules about deploying Azure Stack HCI, you will see we deployed 3 clusters. We have the cluster 20, it's a 2-node cluster. We have the cluster 30, it's a 3-node cluster. And the cluster 40, it's a 4-node cluster. So 3 different cluster types. The reason why we deployed these 3 different types is that we have different capabilities when creating volumes. Let's start with the 2-node cluster. I'm connecting to this 2-node Azure Stack HCI cluster. As you can see, this cluster is not yet registered, but if you review the module about registering Azure Stack HCI in Microsoft Azure and activating Azure Arc, you will see how to register it in Azure. And the reason why I don't have registered the cluster in this demo is to show you that you can create volumes even if the cluster is not registered. The next module, video module number 12, about creating and managing virtual machines in Windows Admin Center, there we will need the registration. Here for creating the volumes not. I will switch to the inventory. And here we can see the cluster performance history. I mentioned this volume in a previous video. We can see this has a size of 20 gigabytes. And here in a 2-node cluster, the default resiliency is two-way mirror. Two-way mirror means in this 2-node configuration with our 2 servers, let's check this. We have 2 servers in this cluster. One server can fail and we will not have any outage regarding the storage if we have only the single server failed. Important that this works, we need a witness, but we have configured a witness for this cluster. You can see this if you review the 2-node deployment video. There we configured a witness. The witness is up and running. So if a disk in one node fails or a complete server fails, our 2-node mirror volumes are still available. We don't have any additional redundancy, so we will not survive an additional failure in the second server, but if we have only one failure at a time, everything stays up and running and the data is available. Let's create some new volumes. I will create a new volume. It's your decision which name to change. For me, it's fine to have the volume 01. And I can see here, I have 3 resiliency types I can use. The two-way mirror means, remember the module about the Azure Stack HCI Basic and Azure Stack HCI hardware requirements at the beginning of this video course. There we have seen that Azure Stack HCI distributes the extents that are created. We learned if we create a volume, storage spaces direct in Azure Stack HCI will create extents with a size of 256 megabytes. For each extent, there will be 1 copy in this two-way mirror, and this copy will be stored on the other server on another disk. So never original and copy on the same server. Let's create the two-way mirror here. We have a two-way mirror. Let's select the size on hard disk with 1000 gigabytes. So 1 terabyte. The maximum volume size would be 15.6 terabytes. And in more options, we can decide if it's a fixed or thin provisioning. Thin provisioning is exclusively available in Azure Stack HCI. We could use an additional integrity checksum that will need additional storage capacity, and we can use the encryption. Let's create this two-way mirror volume. Volume is created always when we create volumes in the Windows Admin Center, the first step is that Windows Admin Center sends the volume creation script to the cluster, and then we will get the result here in the Windows Admin Center. The status is shown in the notifications. The volume has been created. If you want to see it immediately after creation, you can refresh this list manually here. If you don't want to refresh it, just wait a few seconds or minutes. This will appear here. We have this two-way mirror. Let's create another volume. Because what's important to understand, we can have different volumes with different resiliency level. Two-way mirror, I explained to you. A nested two-way mirror means for each extent we have, for each of these 256 megabytes extents that are created, we will have 3 additional copies. One copy will be stored on the system locally where the original extent is saved, and 2 additional copies will be stored on the other server in 2 different disks. And this means with a nested two-way mirror, we can survive a complete outage of one server and at the same time an additional disk failure in the second server. So I would recommend you, I'm an absolute fan of redundancy. So I like redundancy because redundancy saves my workload. And so I would recommend to use the nested two-way mirror. The nested mirror accelerated parity. You remember from the hardware requirements, we need 4 hard disks, no, 4 capacity drives. This can be hard disks, this can be SSDs, this can be NVMEs. We need 4 capacity drives in each server. With a nested mirror acceleration parity, the extents are copied regarding the process across the server. So we have an original extent on server 1, a copy of this extent on server 2. But within the servers, we have nested something like a RAID 5 based on the extent level. And as you know, something like a RAID 5, it's good regarding the storage efficiency. It has reduced performance regarding the writes. So this nested mirror accelerated parity has the advantage that I have at the first step a mirror. It's very fast. At the second layer, I have for the second redundancy layer the parity. This has been calculated by the CPU, yes. The nested mirror accelerated parity is supported for production workload where you have a focus on performance. I would choose for the nested two-way mirror. The redundancy is for both the same nested mirror accelerated parity and nested two-way mirror. In both scenarios, you can survive a server failure and an additional disk failure in the remaining node, or 2 simultaneous disk failures, 1 disk failure in each node. In the two-way mirror, we cannot survive this. So I will choose for the nested two-way mirror because I wouldn't recommend to use the mirror accelerated parity. I will not create this one here. The process is similar. We specify a size on hard disk, size in gigabytes. You can check this. Here we have the information. Maybe I will show it to you because we have additionally these 2 layers. Okay, I will create the mirror accelerated parity also, but I would not recommend to use this volume. Let's create it in the next step and then I will delete it. We have also more options here: fixed thin, use integrity checksums, use encryption. Here we can see I created 2 volumes, and it's recommended for best performance to have 1 or 2 or 3 volumes for each server. It's important, this is only a recommendation. If you only have 1 volume, if you only have the volume 01, storage spaces direct works without any limitations. Both servers can keep active workload. It's an active configuration. You have a very good performance, but if you want to optimize the performance, you would try to ensure that you have 2 volumes in a 2-node cluster, or 4 volumes in a 2-node cluster, or 6-node, not 1, 3, or 5 in the 2-node cluster to optimize the throughput. but these are the last few % of optimization. So you have always to deal with this and check, okay, what's the additional management impact I have with an additional volume? Do I really need it? Yeah, okay. Before we come to the nested mirror accelerated, let's see these two volumes. Here we can see, okay, two-way mirror, nested two-way mirror, the size for both is 1 terabyte. Okay, let's create the third one. And as I mentioned, it's not recommended to have 3 volumes in a 2-node cluster, but it works fine. You will not have any impact that something will not work or you will not have access to something. It's only if you really want to have a perfectly designed configuration, then you would create the 2 volumes or 4 or 6 in the 2-node configuration. Let's create the volume 3 with a nested mirror accelerated parity. You can see I have a new drop-down list here that decides which size the parity layer will have and which size the mirror layer. Parity is here 90%, 80%, 70%. The mirror is 30%. This means if I'm using a smaller parity layer, I can use the mirror layer for accelerating the storage access. So it's an interesting opportunity to have this here, and you will have more storage efficiency. We will see this later when we look at the footprint of these volumes and the usable capacity. But you have to keep in mind that you slow down your storage spaces direct configuration a little bit. It depends on your workload, how large the impact is. And you have to keep in mind, maybe you will need some additional resources regarding the CPU because the parity has to be calculated. And maybe it's a better decision to say, okay, I accept not so good storage efficiency, and I will go with the nested two-way mirror. So please do not keep old standards you used and say, okay, I've heard mirror accelerated parity is something like a RAID 5 that's accelerated. I always use this in the traditional systems. I will also do this here. This is not the recommendation because usually you are more efficient if you choose the fastest, not so capacity efficient algorithm and add the additional needed capacity with larger disk drives. Okay, let's create also 1 terabyte volume size here. Again, we have fixed or thin provisioning, integrity checksums, and the encryption option. So let's create also the volume 3. Volume 3 is created, is sent to the nodes. Here we have the progress, creating volume on the target host in the target cluster here on Azure Stack HCI. Actually cannot be visible because it's still in creation, this volume. When the creation has finished, then we will see the volume. If it doesn't appear immediately, we can click on refresh here. Let's check the volume 01. I will go to the volume 01, and here we can see, okay, this volume has a size of 1 terabyte and it's a footprint of 2 terabytes because it's a two-way mirror. This means every extent has a copy on the other server. Let's check the volume 2. The volume 2 is a volume with an usable size, capacity I can use with 1 terabyte, but it has a footprint of nearly 4 terabytes. Yes, it has 4 copies for each extent, the original and 3 copies, because it's a nested two-way mirror. Let's check the third volume. The third volume here, we can see it has a total size of 1 terabyte and it's something between. Remember our planning for Azure Stack HCI solutions module, where we used the storage spaces direct capacity calculator. And there we could move a slider in a 4-node configuration. And this is similar here for the nested resiliency, but nested resiliency is not available in this capacity planning tool. And here we have something between. We have something like 3.2 terabytes footprint. So we have a better storage efficiency, but usually storage capacity has not this huge impact. Important integrity checksum, we decided to have it off. It needs additional capacity. We could choose for BitLocker encryption, and we can activate the deduplication. So there are different opinions about, oh, I activated the BitLocker, I didn't want this. There are different opinions about deduplication. I'm using deduplication on every test and demo system because it's highly efficient. It has, in these scenarios, only a little impact on the performance. Important is to know that it's not an inline deduplication we have here. It's a deduplication that looks at the data based on a schedule you have, checks the existing content on your volume, and then optimizes the data on the volume in copying duplicate parts to a central store. The deduplication has a great efficiency. I always use it on test and demo systems. I have very good experience in virtual desktop infrastructure environments where we have a lot of similar hosts. The efficiency is great, even if we have absolutely different VMs, but in a production environment with traditional production workload like Exchange, SQL Server, with systems that have very specific requirements, I would be careful with deduplication, except you have your own experience over years and you say, yes, I trust in it. I never had issues with deduplication, but from my experience, I prefer to use it in the scenarios with demo systems and virtual desktop infrastructure. Okay, let's see what's possible here. I can open the volume. I can have a look at the content. I can open a file browser. You will see I'm reconnected to one of the nodes in the cluster, and there we'll find the volume in drive C in the cluster storage. So the volumes are made available on the cluster nodes via a volume mount point, like we know it from traditional clusters, from traditional disk systems. So the path we can configure here and use here is absolutely identical. So let's go back to the cluster. Let's go to the cluster number 20. And let's check a few options for the volumes. As we can see for our drives, now we have some capacity consumed because the volumes were created with a fixed provisioning size. So we have storage used on the disk drives. We have storage used in the storage spaces direct pool. Our reserve is still available, so it's a good idea to check this if we don't violate the reserve here when we created volumes. Now I can check for the volumes. In the summary, I can see information about the volumes overall. Are there issues with the volumes, outages, warnings, things like this? And in the inventory, I can check what's possible with an existing volume. Let's take the volume 01. I want to try, yes, I can delete it, I can turn it offline. I want to try to expand it. Let's expand this volume, volume 01, and let's expand it to 2 terabytes. Yeah, for the information here, I have the new total footprint will be 3.91 terabyte. Let's expand the volume. Expanding the volume is running here. Process successfully executed. Total size is now 2 terabytes. Footprint is 4 terabytes. When I look back to the drives, I see after a short refresh the new used capacity here. Actually, it's not refreshed. We had this 9.14 terabytes also before. But if I reload this page or wait a few seconds or minutes, I will see this additional consumption. No, actually, I don't see it, but stay on this 9.14 terabyte. Keep this in mind, and we will look back to this when we executed the next task. So we will check this again, and you can imagine this will also consume here additional capacity if we extend volumes, if we need additional capacity for the volumes, and for sure, it will also consume additional capacity on the disk drives. So the volume has been extended, volume 01. This was no problem. Two-way mirror, I could extend this via the Windows Admin Center. Let's check the volume 02. It's the nested two-way mirror. So additional complexity in redundancy. Let's try to expand this volume. You can see here, okay, size on hard disk, 1 terabyte. Let's also go for 2 terabytes. And I will try to create and expand this volume. The action is executed, expanding volume. Here the actual size is still 1 terabyte, but footprint is already 8 terabytes. So what we need is some time. Now it's refreshed. Here we can see 2 terabytes. I could expand this volume. Now I have this additional capacity, so no problem to expand volumes if we have available disk capacity. Here we can see now this value changed. We only have to wait a few minutes till we can see this. And in the inventory, if you save this information, we had 29% before we extended anything. Between we had something like 39%. And now we have 48% used. So this extension is possible because we have available capacity. And you can see now we come closer to the reserve capacity here. Let's try the third volume we created, the volume with the nested mirror accelerated parity. This is the most complex storage configuration we can have in the two-node configuration. Let's try to extend here. Let's do the same. I want to expand it to 2 terabytes. I could also switch to terabytes here, yes, but we started with gigabytes, and this is the reason why I have kept the gigabytes. Let's try to expand here. We have expanding the volume 03. The volume was expanded according to the process here. Let's see what happens. Footprint is already updated. Total size is always updated. If you try the previous version of Windows Admin Center, you will have seen that Windows Admin Center was not capable to, or was not able to expand this complex volumes in previous versions. Now Windows Admin Center can expand all resiliency types in the two-node cluster we can choose here. Let's go back to the drives. Maybe it's already refreshed. Here we can see 15 terabytes used in the inventory. We can see still 48%. So it will need some additional seconds or minutes till we have the full update here. We will check this in a few minutes or seconds. So as you have seen, the extension or the expanding of a volume is very easy. It's possible here, only click, choose the new size. If we have available disk capacity that can be consumed, and we can check this in the disks, how much capacity is available, then this volume can be created or expanded. I cannot reduce the size of a volume. This is not possible. This is not possible for this easy two-way mirror. This is not possible for the nested two-way mirror. This is not possible for the nested mirror accelerated parity. It's also not possible in the 3 or 4 node configurations. If I realize, oh, volume 1 is too large, I want to have a smaller volume 1, then I have to create a new volume 4. Now this volume maybe has a capacity of 500 gigabytes. Then I can create this. I can move the workload from volume 1 to volume 4 via storage live migration without any impact on the running workload. And then I can delete volume 1. So I can expand it, I can delete it, but I cannot reduce the size of a volume today. So this is not possible. And as we have learned in several video modules, the consumption on the disks, if we have used thick provisioning or the fixed provisioning, is already there when we create the volumes. So let's go back to the summary. Here we can see now we come closer to this reserve capacity. So let's try to expand our volume 4. I will expand my volume 4 to, let's say this is also planned to be a 2 terabyte volume here. This is what I want to do with this volume 4. Expand it. I can see first the footprint should be updated. Then we will see the new total size, where it's very close at the same time. Then let's wait a few seconds and then we check what happens at the disk drives. Important is when I scroll down, I can see for this volume here, the volume 4 with the two-way mirror, the IOPS, the latency, the throughput. Actually, we don't have a workload here, so there's no many data here, but we could see it here. We have actually no virtual machines. This will change in the next module where we create virtual machines. And we have our storage tiers. The storage tier is here, two-way mirror. All the size is on this two-way mirror with 2 terabytes. Let's compare this with the other volumes, because we have also the volume 2 with the nested two-way mirror. Let's check the storage tiers here. Here we have the nested two-way mirror with the footprint. Now let's check the volume 3, where we have this combination of mirror and parity. When we go to the storage tiers here, there we can see, oh, we have 2 storage tiers. So the data is distributed across the nested two-way mirror for acceleration. It works exactly as I described it in the nested mirror volume. And we have an additional layer. It's a single parity. It's not a dual parity. In 4-node clusters, we have a dual parity. It's a single parity with a size of 1.37 terabytes. And the mirror accelerates the parity. Yes, this is true. But compared in the whole stack here, the fastest volume will be, with the full redundancy, the volume 2. So this is what I would recommend to create and to use here. So let's check the drives again. What happens here? Now we are very close to this reserve. And reserve, this sounds like, okay, nobody can consume this. Let's try what happens if I expand the volume 4 again. We'll take this volume 4 and I will expand this volume by additional 500 gigabytes. This is too much. 500 gigabytes. Size is too large, it says here. Okay, let's try a smaller size. Let's try to have 2.200. Oh, it's still, oh, I have the terabytes. Sorry, it's my fault here. Now with the gigabytes, it should be possible. Yes, 2,500 gigabytes. I can expand the volume. It's very fast in expanding, but be careful, you cannot reduce the size. And now I have to wait again a few minutes to see what happens with the drives. And what I explained to you, it's important that you review the reserve capacity manually, because keep in mind, we discussed this, the reserve capacity is not a reserve drive. So regarding our drive inventory, we don't have any drive that's there for rebuild actions. But if we configure everything correctly, we will have on every drive a little capacity. In this configuration, where we have 4 times 4 terabyte drives, we will have a free capacity of 1 terabyte on each drive. So if one of the drives fails, I can rebuild this 3 terabyte data that was stored on this drive with the 3 remaining drives in this server. But this only works if my reserve capacity is available there. So if I consume it, and you will see the next step is when I expand it again, that I will reach into this reserve capacity, and I will only demo this here. I will not demo this in the 3 and 4 node cluster because it's absolutely identical and similar there. Let's go to 3 terabytes here. Yeah, it's terabytes. Let's go to, yeah, we can also go to 3 terabytes. This would also be possible from 2.5 to 3 terabytes. Let's try to expand again. The volume is expanded. You can see the additional size, 3 terabytes. And now we will see that this hangs into the reserve capacity. And this means that the rebuild action will not be possible automatically. So then if a drive fails, the rebuild starts when we replace the drive. If we have the reserve capacity remaining in the server, then we have the situation that the rebuild will happen immediately. So it's a trade-off you can decide for. The reserve is 8 terabytes. Yes, this is data. Yes, this is capacity. This costs money. But if you have a drive failure and you don't realize it, maybe it's in middle of the night, it's at the weekend, it's on Sunday, then you can be sure if you have the reserve capacity that the rebuild will start automatically. If not, it waits till you replace the drive. Okay, the impact is we have full redundancy for each volumes. So if one drive fails, I don't have an impact for volume 1, no for volume 2, no for volume 3, no impact for volume 4, also not for the cluster performance history. But if I have the reserve capacity free and remaining, then the situation is a drive fails, the rebuild starts. When the rebuild has finished, the redundancy is the same redundancy I had before the drive failed. I have one drive missing, but I have back the full redundancy. So I can survive additional disk failures. This is important for volume 1, where we only have the two-way mirror. For volume 2 and 3, we have additional redundancy, even if this drive keeps failing and it will not be replaced. Now for me, the situation is if I want to free the reserve capacity, I have to delete a volume. I cannot reduce the size. And this is the reason, always check the amount before you expand. And if you have huge capacities, then ensure if you have the right option chosen, gigabytes of terabytes, to ensure that it's not much larger than you expect. Now, when I go to the drives, maybe it's not refreshed here. You have seen this always takes a while till we have the information here in the Windows Admin Center. I think here it's already done. So in the summary, now I have the free capacity back. Okay, one last step in the two-node cluster. When we have created our volumes, we should ensure that our drive path for creating virtual machines is customized. We find this in the general host settings. And in the general host settings, we can see the default drive is this C users and C program data. This is the default value in each Hyper-V deployment, but this absolutely doesn't make sense for a server. So I will browse here and choose for another path. And we already have learned it's drive C, it's the cluster storage. We are not on the Windows Admin Center machine. We are on this machine 20. And my preferred volume is the volume 02. This is the volume where I have the opinion that this volume is the best choice for a two-node cluster. It's nested two-way mirror, so maximum redundancy and best performance. What's important, you have to create a subfolder here. I will create a subfolder VMs because you cannot store your VMs direct in the root folder of this cluster storage volume, the volume 02. I will select the VMs folder and I could copy this path or click on browse again, go to drive C, the cluster storage, the volume 2, and here the VMs. I can select this. Okay, now save. And now our two-node cluster is configured correctly regarding the volumes, and we have already a suitable default drive path. If you remember the Hyper-V Manager, there you had to configure this default path on each node. In Failover Cluster Manager, it was not possible to configure this default path. In Windows Admin Center, we have this central location. So let's switch to the 3-node cluster. We spend a lot of time in the 2-node cluster because we have very interesting options there. Let's go to the 3-node cluster here, our cluster number 30. Here we can see the 3-node cluster. Actually, everything is up and running. I have a warning here. This is an issue we actually have in Windows Admin Center, that it sometimes warns that you are running out of capacity, but this is not correct here. Let's check the servers. I have 3 servers in this configuration. It's a 3-node cluster. I have a witness configured. My drives I have here are nearly empty. I have nearly no capacity consumed. I have more reserve capacity because I have a specific amount of free capacity on each drive, on each server, to be able to have this automated local rebuild. Because I have the 3 servers, each server 4 drives, each drive with 4 terabytes of size. I have 12 terabytes overall as reserve, so 1 terabyte on each drive. In the volumes, we have the cluster performance history. This is the default volume for the cluster information and performance data. It's okay. Now we can see, oh, this is a 3-way mirror. This is something new. So let's create a new volume, volume 1. And here we can see the only available redundancy or resiliency level is the 3-way mirror. The 3-way mirror means I'm creating a volume, and when I create the volume, for each 256 megabyte extent, there are created 2 copies, and each of the copies is written to another server. So I have 3 servers, 3 copies across the servers. I explained this in the Azure Stack HCI hardware requirements in part 2 of this video series. So let's create a volume with 1 terabyte of size. And we will see similar options: fixed or thin provisioning, integrity check, zoom. Let's use the encryption, create the volume. The volume is created in the cluster. After we have a refresh in the Windows Admin Center, we will see the result here. We have the similar actions: create, open, expand, online, offline, delete here. And in the 3-node cluster, we will see the footprint of the volume. It's a 3-way mirror. Again, to explain, we can survive the failure of a server. So one server can fail and another server can fail completely without any data loss. One server can fail and a disk drive in the other server without any downtime and without any data loss. What's the difference? When we have a look at our drives, then we can see our drives. We have 4 of them in each server. This means I have here, let's do it without zooming. I have 4 drives in the first server. I have 4 drives in the second server. And I have 4 drives in the third server. Now we have a requirement for Azure Stack HCI and Storage Spaces Direct. To keep everything online, we need a majority of the cluster votes. This is decided on behalf of the nodes have a vote and the witness has a vote. This is the basic cluster functionality. Then for sure we have the requirement to not violate our resiliency level. In a 3-way mirror, we have 3 copies, so we could lose 2 of them without losing any data. And this is the situation if we lose, for example, this server completely and an additional disk drive. We cannot lose an additional disk drive in the first server now, but we can lose an additional disk drive in the second server. But if we lose the next disk drive, we have the situation that we don't have the disk majority any longer. To keep the pool online where the drives are part of, I need the majority of disk drives, and this is not the case if we lose this disk additionally. So it's important to understand that also the majority of disk drives plays a role. This means if this drive fails or the complete server fails, I will not have any data loss because I have the redundant information here on these drives, but I will have a downtime for my workload because the pool goes offline. So let's check the volume, the three-way mirror we created here. I mentioned we should create a second and a third volume to optimize the configuration, but it also works with only one volume. I will only work with this single volume because I explained to you perfect design is it if we have 3 volumes in the 3-node cluster or 6 volumes in the 3-node cluster or 9 volumes. I will only work with this single volume. We can see here the size is 1 terabyte. The footprint is 3 terabytes. 3 copies, yes, it makes sense. Let's expand this volume to 3 terabytes, or let's take 4 terabytes, a 4 terabyte volume. We will expand this one here. Volume is expanded. We now can see the total size 4 terabytes, footprint is 12 terabytes. When I scroll down here, the storage tiers, I have the full amount of data on the three-way mirror level. When I now switch to the drives, I can see I have some consumption here. It's actually not updated in the inventory. I will see I have the consumption on the drives because the volume is there and it's expanded. And in the summary, I will see the whole consumption. As I mentioned, this screen is actually not up to date. I need to wait a few more seconds or minutes till it's updated. But what I already can do, I can go to the settings, and I mentioned I have to configure in the general settings the path. I will here choose for the volume 1. So let's browse here to the cluster, to cluster drive C, the cluster storage, the volume 1. And as I mentioned, we need a subfolder, something like VMs here or virtual machines. So based on your naming convention, and I will select this one. And I will select it here also for the virtual machine path. Otherwise, I will run into issues when I try to create virtual machines later on this cluster, because in Windows Admin Center, it's not so easy. It was in Hyper-V Manager to choose a different path. It's possible, but if the default path is completely wrong, I usually will run into issues. Okay, let's save this here. So the last cluster type we have is our 4-node cluster. Let's check what's available here in volume creation and management. So the interesting thing is 4 nodes, but there's not a 4-way mirror. This is important at the beginning. Let's check the nodes. Servers, let's verify we have 4 servers in this cluster. Yes, we have 4 servers here. Let's check the drives. You can see nearly no capacity is consumed. Nearly something like 60 terabytes available. In the inventory, we can see each server has 4 drives. My servers always have these 4 drives in the demo environment, but for sure we can also have additional drives. Without cache drives, it's possible to have each number of drives. With cache drives, we have to care about the relationship between cache and capacity drives. I explained this in the module about the hardware requirements. For us, it's very easy to understand how it works if we always have the same drive size and the same amount of drives, and only the number of number of servers changes. So let's go to the, and you can see nothing is used on these drives. Let's go to the volumes. And let's create a new volume. We can see again the cluster performance history, and it's a 3-way mirror. This is what I mentioned. We don't have a 4 or 5-way mirror. 3-way mirror is, let's say, the maximum mirror redundancy we can have. Let's create a volume 1 3-way mirror, size on hard disk 1 terabyte. I want to create this 1 terabyte. More options. You can see the same options we had in these 2 different other cluster types, and create. And we will see a 3-way mirror is created. So important is we will not have the situation that this is a copy between 3 servers and the fourth server is out of it, because we have extents with a 256 megabyte size. So every server will have original extents, every server will have copy extents. So the volume is distributed across all 4 servers. We have 3 copies, but this doesn't mean that we copy servers or drives. We will check this in a few seconds when the drives list is refreshed. We have seen the drives were empty when we started. Now we can see on every drive, on every server, we have consumed some capacity by this volume number 1 as a 3-way mirror. Hopefully this is clear to everybody. If not, feel free to send questions about this to me, because this is very, very important to understand. We don't have passive nodes. All the nodes are active, especially regarding the usage of disk drives. Let's check what's also possible. When I create additional volumes, in volume 2, I can see, oh, there's no nested 2-way mirror. There's also not a nested 3 or 4-way mirror. The nesting is only available in the 2-node cluster. Because in the 2-node cluster, it's so difficult if one server fails. In a 2-node cluster, we cannot have a 3-way mirror because there's no third instance as a fault domain. The fault domain level here, the default fault domain level, is server. So this is the instance storage spaces direct looks on, and where storage spaces direct ensures that we have redundancy across these elements. But the mirror accelerated parity is available. So we have again the situation we can create a volume that has a part of its capacity as mirror, the part of its capacity as parity, described the parity comparable to a RAID level. Here we'll see it's not comparable to RAID 5, but to something like RAID 6. And now I can again decide about the relationship. Let's do 70% parity, 30% mirror. Let's create the 1 terabyte hard disk size, 1 terabyte volume size. I will create this one. Now I have 2 volumes. The volume 1 is this volume with a size of 1 terabyte. The footprint is 3 terabytes. Yes, this is the 3-way mirror. Let's go back to the volumes. The volume 2, when it's created completely, creation volume finished. I have to update here. The volume 2 has total size 1 terabyte. It has a more efficient footprint, but keep in mind the parity has to be calculated. And when I check the storage tiers here, I can see there's a part of the capacity in a 3-way mirror, very fast, high performant. My recommendation regarding the footprint, I have some disadvantages. And I have a part of the capacity in the dual parity. It's not RAID 6, but I mentioned it's comparable to something like RAID 6. So we have a double parity, a dual parity here. So we can survive in a 4-node cluster with 3-way mirror volumes or mirror accelerated volumes. The outage of 2 servers without any data loss, but then we cannot survive any additional failure. Or we can have 2 independent storage failures. If we lose 2 servers, we lose 50% of our disks. We have still the disk majority because there's a pool owner. For the storage spaces direct pool, I mentioned every server in the cluster can write and read from the pool or from the volumes on the pool at the same time, but one server is the pool owner, and this server has an additional vote. So if we lose 50% of the disks, we still have the disk majority, and we don't violate our resiliency level. So let's check the volumes in the inventory. I will try to expand the volume 1. We will see expanding volume 1. If I have enough capacity, let's take something like 4 terabytes available on hard disk, 57 terabytes, new total footprint 12 terabytes. I will expand this here. Total size 4 terabytes, footprint will be 12 terabytes. No issue, this works. When I go back to the volumes in the volume 02, Let's try to expand this one with the 2 different storage layers. It's also possible to do this via PowerShell, but it's a lot of work because we have to expand the 2 storage tiers. We have to expand the 3-way mirror tier, and we have to expand the dual parity tier. And so it's much easier to do this here. Let's also choose 4 terabytes, expand it here. We can see the new size with 4 terabyte and the footprint. And again, what I mentioned, recommendation for perfectly designed configuration would also create a volume 3 and 4. I think what's perfectly to see, we can have different resiliency types. So if we want to have a performance optimized volume, we can take the 3-way mirror. If we want to have a capacity optimized, we can take the mirror accelerated parity. We can use different capacity relations between mirror accelerated parity and 3-way mirror. And the last step again in this cluster is also to customize our path for the Hyper-V settings. I will do this here for this machine here, finally, to have it prepared for the next step in the next video to create the virtual machines. I will choose the volume 1 because this is my preferred one in the 4-node configuration. It's the 3-way mirror. And this is what sometimes it's a little bit difficult for people that are new to Storage Spaces Direct to understand that a 3-way mirror is possible with 4 nodes, with 5 nodes, with 7 nodes, and that we don't have any additional redundancy. We don't have a 4, 5, 6 way mirror, except the situation where we have a stretched cluster, because in the stretched cluster we have additional redundancy through the usage of storage replica. And in the 2-node cluster, we have additional redundancy in building local copies also on the drives. I will save this. And now we have seen everything about creating of volumes in the Windows Admin Center. If we have 5 nodes or 6 or 7, 8 nodes and so on, the capabilities are similar to what we have seen in the 4-node configuration.